All right, so here we're going to do our run through of station 2 of where we're going to have 4 different equations, and we're going to match them up with linear, quadratic, cubic, and exponential, and talking about finding some of the missing values for these 3. All right, so let's go ahead and start off here. So remember, it's all about looking for that change. So to go from 0 to 2, I'm going up 2. And as we kind of go down, you'll notice on this one that each time we're changing 2. So if we're changing by the same thing right away, that's what makes us linear. And this is the one scenario where we actually want to use this number. And we put it with our x, and then there's also a missing bonus number there. To find that missing bonus number, you'll just take a coordinate point, and you will plug it in for your y and x. So here, 8 is y. And then our x here will be a 2. Okay, so if we continue to sort this out, this piece right here would give us, see, I'll take it this way. We'd have that 8 is equal to 4 plus something. All right, so that has to be a 4. All right, so with this being a 4, that will complete our equation of what we can put up here, which is y is equal to 4x plus the 4. Right, and these numbers won't always be the same. That's just a coincidence on this one. This first 4 came from, oh no, it's a 2. Hold on, sorry. Let's say, I don't remember that. And let's change this here. All right, we found our rate of change number to be a 2. So it's 2x plus 4. The 2 coming from this row of 2's. And then we found that bonus 4 by setting it up, picking a coordinate point, and solving for that bonus number. Okay? So let's check out the next one here. It's all about finding the changes. So this one goes down by 12. And then we're going down by 4. And then we go up by 4. And then we go up by 12. So it is important to notice the changes here. When you're going from 16 to 4, make sure you acknowledge that you are subtracting 12. Otherwise, it's going to mess up your ladder rungs. So then here, to go from negative 12 to negative 4, that's increasing by 8. Here's increasing by 8. Here's increasing by 8. All right, so it took us 2 tries to find it. Now, that tells us where to stop, but we are not going to use this 8 for anything. This 8, since we're not linear, will not provide us any information. But since it took us 2 tries to find that constant, we're working with this scenario here. But then beyond that, it's the same concept of picking a coordinate point and plugging it in for our y and our x to help us find that mystery number. And we're plugging in 2 here. Okay, so this right here, 2 squared gives us 4. So 4 times a number will have us equal out 16. And so that has to be 4 times 4. So I know that mystery number is a 4. So back up at the top of our equation here, we will have y is equal to, that bonus number was 4, and then x squared. So notice, like I said, we did not use that 8. That just told us to stop searching for a constant. Right? There'd be our equation, and you can check this with any of those different coordinate points that you want, and it would work out for all of them. All right, on to the third one. We had talked about if you see decimals, and then a couple rungs later, like a bigger whole number, that's usually denoting that it's going to be exponential, which is in fact what's going to be going on here. If you were to make tree diagrams, it would never end, but this is where you'd have to notice, hey, you know what? I'm not adding or subtracting by the same thing over and over again, but we are multiplying. I'm multiplying each time by 2. All right? So similar to the linear sense, if we are multiplying all by the same number, we are going to want that 2, and here's how it works. We're going to put the 2 down low with the x up top. And that's how exponential work. And I won't toss us in any bonus numbers with the exponentials. because it would make it a little more complicated, especially with x being up here in the numerator spot. So don't worry about that. It'll just be up to you to determine, hey, this one isn't adding or subtracting over and over again. We are multiplying. All right? So we've done 3 of them so far. We had linear, quadratic, and exponential. All right, so we did our linear one, our quadratic, and our exponential. So we're anticipating this last one to be cubic, which means it should take us 3 rungs on the ladder to find that change. So let's go ahead and find that here. So here we are increasing. We're increasing by 35. Here we're increasing by 5. Here we're increasing by 5. And here by 35. All right, so when we go to our next rung here, this time we decreased by 30, changed 0 from 5 to 5, and then we increased by 30. And so now this third rung on the ladder finds that constant change of 30. So once again, we're not going to use this 30 for anything. It just told us that we can stop searching on our tree diagram, and we can set up our equation as y is equal to some type of bonus number, and then x to the 3rd power, because it took us 3 rungs to find it. All right, pick a coordinate point. You can't actually use the zeros on these, because that won't help you cross-reference to find this bonus number, because zeros just cancel everything out. And you don't have to pick the biggest coordinate point if you don't want. So let's pick the 1 and the 5. All right, so if I plug in 5 for y, and there's my bonus number, 1 for x. 1 to the 3rd power is just 1 times 1 times 1, which is 1. So I have 5 times some type of number multiplied by 1. That number has to be a 5. Okay? And we would have found, I'll leave that there, we would have found that same answer had we have used a different coordinate point. Say you did want to use a larger coordinate point. I'll showcase that no matter which one of these that you use, you'll find that same number. So say instead here you wanted to use the 2 and 40. So we have 40 is equal to some type of number times 2 cubed. 2 cubed is 2 times 2 times 2, which would give us 8. So then I'd have 40 is equal to some type of number multiplied by 8, and it's 8 times 5 that gives us 40. So there's that same existence there. This equation is y is equal to 5x to the 3rd power. So make sure you kind of run through a couple of these and understand some of their small but essential differences. And that's the end.